Hi all, my name is Dræge and I'm head of the team for machine learning and artificial intelligence in the Norwegian insurance company Frende. Frende is growing, but still relatively small, and we are completely dependent on smart and efficient solutions to be able to compete with larger companies. Today I will present the workflow and result of a project where we combine data engineering, AI models and robotic process automation to increase the automation degree when handling resigning customers. I would like to start this talk with a quote that I think relates to our work. Creativity is thinking up new things. Innovation is doing new things. The work presented in this talk is not about developing new technologies or inventions. We have just combined competence and technology already existing in Frende in a better and smarter way to achieve better results. And that is what I mean with innovative work. First, I will go through the background for this project. Then I will say some words about robotic process automation and its role in Frende. I will present the new interdisciplinary workflow and the automation results after implementation. Finally, I will sum up what we have gone through. The insurance market is volatile, with customers constantly looking for best products and best prices. Every year, Frende receives more than 18,000 emails concerning the resignation of around 12,000 customers. It's a huge job to read all these emails, look up the customers, and complete the resignations for customers not to be rescued. We estimate the processing time to 10 minutes per customers manually handled. In August 2018, the RPA team implemented a process that could handle 25% of the resigning customers. This was done by rule-based algorithms to recognize if the customer resigned from the whole portfolio and to find the termination date. One reason that the automation degree couldn't exceed 25% is that all companies send in resignation on different formats. And some companies also have more than one format. Also, some companies send one resignation email for each product the customer is resignating from. Therefore, a rule-based system would need to be tremendously large and complex to account for the majority of resignations. With this background, we thought it could be a good case for artificial intelligent text analysis models. Before starting, we defined some goals for the project. The primary goal was to develop and implement a new workflow that involved data engineering, data science, and RPA. In addition, we wanted the workflow to be able to identify at least 80% of the completely resigning customers with sufficient confidence to let the robot handle the resignation automatically. I would like to show you some examples of what a resignation email can look like. The emails typically have the relevant information as an attached PDF file. In this figure, I have hidden all sensitive information, but the information that we would need to obtain is name and birth number of insurance holder, the product that is resigning, registration number where that applies, and the date of the resignation for each product. The PDF document is converted to text, which might look a little messy, but it still contains all the relevant information: name and birth number of insurance holder, product, registration number, and date of resignation. We clear up the text before applying machine learning on it. I have included some other resignation PDFs to show some of the variation. In this example, we got 2 emails for same customer, one with resignation of 2 car insurances and one with resignation of boat, content and travel insurance. Note that all insurances have their own specified resignation date. In this case, resignation date is common, but it doesn't have to be. Robotic process automation, or shorts RPA, is a software technology that makes it easy to build and deploy software robots that emulate human actions. Today, the team for robotic process automation has automated work that corresponds to 41 man-years in Frende, which is approximately 15% of the total man-years in Frende. This is a result of a good and collaborative culture, where opportunities for automation is continuously looked for in all parts of the company. The RPA team initially relied on rule-based workflows and has completely or partially automated numerous processes in Frende. But some processes are more difficult to automate, especially those that include free or unstructured text. And this is where artificially intelligent natural language processing models come into the picture. By combining robotic process automation with language models, we open up for a new level of automation that is likely to have significant impact on the total automation level in Frende. One such process that was taken into the next level was automated handling of resignations. In this project, the robot is receiving the resignation emails and apply rule-based algorithms to recognize resigning customers. Resignations, where the robot is uncertain if all products are resigned or it can't get hold on some key information, are passed on to the AI model. Finally, the robot executes all resignation that qualify. NLP is concerned with how to program computers to process and analyze large amounts of natural language data and use it for extracting information and insights. BERT, which stands for bidirectional encoder representations from transformers, is a popular example on NLP models. One of the key factors to the success of BERT is the possibility for bidirectionally training, which leads to a deeper sense of language context and flow. The model was published by Google in 2018 and outperformed the state-of-the-art across a wide variety of tasks. BERT was originally trained on 3.3 billion English words, but have later been trained on all kinds of languages. It's a huge job to train BERT from scratch, since it contains 110 million parameters. In this project, we use a pre-trained BERT model that has been trained on 1.9 billion Norwegian words. This version of BERT is called NorBERT and was released in February this year. It's said to be specifically applicable for Nordic languages. To train the model on our own data, we needed to identify attachment with resignation of all products. We trained the model on around 1,000 resignation text for each product. BERT was highly effective on identifying various products. To minimize the danger of wrongly predicting a resignation, we require the probability to be at least 0.8 for BERT to classify it as a valid resignation. If BERT should fail to identify one or several products for resignation, the resignation will be marked as partly resignation and transferred to manual handling, and no harm is done. The consequences of wrongly resigning a customer is higher, so we definitely want to avoid that. I will now go through the new workflow developed for this project. We developed an interdisciplinary workflow that involved data engineer, data scientist, and RPA. The first step is to gather all relevant information about the resigning customer. By identifying all products, we will know which products to look for in the resignation text. Resignation number on all vehicles will both help to identify a product and to count numbers of, for example, insurance that have resigned. Knowing the brands of the insured objects can also assist in identifying the products. For products that cannot be identified directly by resignation numbers and brands, we apply AI. One AI model was trained for each product. The model was very capable of recognizing the products, so we could easily apply a probability cutoff of 0.8 to accept a prediction. When summing up all the resigning products for a customer, we compare with the initial product portfolio. If these coincide, the customer birth number and resignation dates are sent to the robot for automatically completion of the resignation. I will show some results that we have gathered since the AI model was implemented the 24th of February this year. This figure shows a rolling average of daily resignations in the 2020 and 2021. The comparison is reasonable since we have not had a net resignation increase in 2021 compared with 2020. Doubtlessly, there has been a significant increase in average daily automatic resignation after AI and data engineering was included in the workflow. The actual number of daily automatic resignation for 2021 is somewhat higher since we are applying automation for more arms. If we look at the relative change, the increase in daily automation varies from 0 to almost 300%. There seem to be some seasonal variations, but on average, AI increases the automation with 94% compared with the 2020 level. If we convert automated resignations to work hours saved, we get a significant number of liberated work hours that can be spent on more value-creating activities. The cumulative plot here shows that in the 203 days of monitoring, 194 hours of work has been automated. This corresponds to more than 1/5 of a man-year. When we look at the actual share of customers automatically handled, there are some interesting observations. The red curve shows the actual automation degree in percent for 2021. The AI-based workflow was implemented in the end of February, and we immediately see a significant increase in the fraction of emails that are automatically handled. The black curve shows the fraction of resigning customers recognized by AI and reported to the robot for automated resignation. While the automation potential mostly lie between 80 to 90% and averages to 86%, the actual automation degree is 71%. The discrepancy can be explained by various causes. Sometimes customers' consultants manually handle resignation emails before the robot manages to handle it. Customers with an ongoing claim or with warranties from another company are also treated manually. But despite these exceptions, we manage to have a high automation level over time. The work described here is a result of good and targeted collaboration between 3 disciplines: data engineering, data science, and robotic process automation. Combining AI with customer information from data engineering was essential and resulted in better performance than what would be achieved by AI or data engineering separately. We had regular project meetings where problems and potential solutions were discussed. The project lasted for 4 months, but none of the involved personnel was involved all of the time. There are some limitations with the AI model that we know about, and for now, accept. If we see that our customers have 2 house insurances, for instance, we have not trained our model to recognize the number of similar insurances that are resigned. As I mentioned before, this is not a problem for vehicle insurances, since the registration numbers are easily recognized and countable. Our models read all termination dates, but they are not linked to a specific product. Therefore, in the few instances where more than 1 termination date is observed, the resignation is sent to manual handling. Further, there are some customers that resign online from part of their portfolio and leave the rest of the resignation to their new insurance company. These customers are also still handled manually, and so are customers that only resign from part of their portfolio. Many of these limitations can be overcome with an extra effort, and we could rise the black and the red curve on the last slide with some percents. But for now, we consider the impact of small improvements too limited, and other projects will be more rewarding. Innovation is often faster and cheaper than large research projects with new technology. Many companies are likely to have large efficiency and automation potential by using existing technology in a smarter way. One common barrier for innovative thinking is getting different disciplines to talk and work together. That can rely on both disciplinary barriers, like understanding of terms and expressions, as well as personalities. In this project, we established a common understanding of the goal in an early stage and worked closely together until we reached it. And that was the key factor for success in this project. It's also important to be able to measure the results, to quantify the improvement. This is important for evaluation of the work, internal marketing of the project in the company, reporting to leaders, and justify our efforts. The workflow and the experiences in this project can be transferred to similar projects where various disciplines need to collaborate. When most of the low-hanging fruits are picked, this is a natural way to go for further automation of processes. The automation enables work hours to be transferred to more value-creating tasks, which result in increased efficiency and competitive power when Frende tries to keep up with larger insurance companies. And with this, I would like to thank you for your attention.